7, last one for Unit 7, just part 2 of Trig applications. So we're just doing some more word problems, if you will. And looking at that first one there. So in the diagram, QS is 32, angle PQS is 50, and angle RPS is 61. So first thing is label the information. Okay, you have to be able to manage information. Okay, so if we do that here. So QS 32, PQS 50, and angle RPS is 61. Use information in terms of length of QR. So we're trying to find the whole length of QR. So this is a kind of a, I don't want to say roundabout, but this is a problem where you got to kind of work around it. So what I want to do is, you got this might help, Maddie. Whenever you have a right triangle and you have an angle on a side, you can use trigonometry. Two pieces of information will help you get the third. Because when you're doing your ratios, I think one thing that's being lost and helping some people this morning is this. So means sine of a degree equals opposite over hypotenuse. Cosine of a degree equals adjacent over hypotenuse. And then tangent of a degree is opposite over adjacent. Now the reason I'm writing that, and you're like, yeah, we know that. But some people don't realize that the degree always goes here with the trig. This is the ratio of the sides. Trigonometry is this. You have your trigonometry ratio of sine, and a degree is equivalent to the ratio of these two sides. So what we're doing is that's what the ratio helps us with. And when you have two pieces of information, you have the degree, you have a side, solve for that one. You have a degree, you have a side, solve for that one maybe. Okay, so you always have 2 of 3. If you don't have 2 of 3, you can't use trig. But that's why this problem here, this triangle, they gave me 2 pieces of information to it. Now they're saying to Mr. Banker they want QR. That's correct. But to get QR, I want to figure out RS and add it to QS. So everybody see that's where we're going? I want to get RS and add it to QS. So you're like, well, why don't you just use trig on the second triangle? Well, look at the second triangle. How many pieces of information do I have? 1. So we want to get a second. We want to get this right here. If I get this side, I now have 2 pieces of information. I can use my trig. Okay? So here we go. Sorry, my voice has been dying on me here. So we want side opposite. We're given adjacent. We want opposite, we're given adjacent, so OA. Tangent, TOA, okay? Tan 50 is equivalent to x, this is x, over 32. Okay, so why did I set that up? Tangent of the degree, 50. Opposite, we don't know. Adjacent, we know. That's the missing piece. We're trying to find the opposite side. How do we find it? What do we have to do? Right, we want to times the 32 over. We're solving for a variable. So that's what you're going to punch in. 32 tan 50 is what x is. When you do that, you should get 38.13. 14, okay. It's a calculation. So we now have an information in the big triangle. We have 38.14. I want RS, right? What ratio am I going to use to find RS now? The same, yeah, tangent again. I want opposite, I have adjacent. It's the same setup actually. Tan 61, x, we'll call it y, just I don't like using the same variable twice. Y over 38.14. Same move, times 38.14 over. Okay, and what did you guys get there? 68.8. So now we add these two. Or no, we don't. We add 32 to this to get the whole distance, which gives you 100.8. Or you can say 101 if you want to round. Does it say, yeah, to the nearest millimeter, so 101. There's 101 because I got 100.8. Okay, questions there? What do you think, Raj? You get it now? You sure?
I was confused why you didn't use the 38
class
plus
change.
38.
Yeah.
That was like that x.
Right, we didn't use a 38 because we want this side. That's a 32 plus what we just got. Anything else? Okay, let's look at example 2 here. All right, calculate the measure of BEC to the nearest degree. So BEC, we're trying to find this spot here. So again, okay, Denise, why can't I get it right away? See, there's only one value. I only know the 4.6. I have nothing else to help me figure out that angle. That's the problem. So we want to find this side, and then we'll have two pieces of information. Okay, just like we just did last one. So again, this one though, opposite we want, we'll call that x. We have hypotenuse. So OH, sine. So we're going to go sine of 39 equals x over 3.7 times 3.7 over okay, that calculation should be 2.328. So this right here is 2.328. So if I'm trying to find this degree now, what relationship do I have? What trig ratio is that relationship? Excuse me. What did you say, Luke? Cosine. It's adjacent. I have adjacent and I have hypotenuse. So cosine of x degrees, sorry I used a variable twice, but it's degrees this time, equals this value over the hypotenuse of 4.6. This is where we were just talking to Maddie about. This is when you inverse. How do we get the x by itself? We have to do inverse cos. That's how you get rid of it. It's that guy. Cancel. That's what you're putting in your calculator. Yeah, 2.328. 2.328. And you should get about 59.6, which will round up the nearest degree is 60. So BEC is 60. Okay, questions or concerns with that? Kate. This one here, I'm going to pause it. I want you to see if you can draw the information in correctly. Okay? There's one like this on your review. But I want you to see if you can draw this correctly. All right, okay, in terms of labeling, it already has a drawing for you, but you guys have to be able to draw this on your own. Okay? So remember, the angle depression, remember, if you're going angle depression or elevation, you have to have like your straight view. Elevation's up from that, depression's down from that. Okay? So when it says elevation of, what was it, 24, that would be right there. So here's my straight ahead, 24. That's my elevation. My depression would be 56 right here. Okay, that's the setup. That's all you have to do for setup, except for they're 45 meters apart, so this is 45. That's the only drawing you need. So now your goal is to figure out the height of the Metro building and the height of the Gamma Pro building, whatever it's called. So one thing that's important to understand is that this is a 90, right? What's this angle? Yeah, it's 34. This has to be 90, right? So then what's this have to be? It's the 56. This will be 34. They have to have that relationship, right? Because they have to add up to 90. So you can see these two triangles are the same triangle. That's why those of you guys that drew, like he drew, like for example, on the warm-up, Aiden drew this triangle for the bus thing. I drew this triangle. They're the same triangles, they're just turned. So they still seek the same results. Does that make sense? Okay, so all I'm going to do now is I have an angle, I have a side. You guys can do whatever you want, but I'm going to do opposite over adjacent. So I'm going to have tan 50, 56. Tan 56 equals the Metro building over 45. I'm going to times 45 to both sides. Okay. What was that calculation? So MB is going to be 67, 66.6 repeating, or 66.7. We round the nearest meter. 67 is the Metro building. We good? Okay. And then we want the big guy. So the big guy, we know this part of it's 67. Okay. So we need to do this triangle to find the extra piece. Okay. So the extra piece is going to be opposite over adjacent. We know if this is still 45, that's the same distance. So you're going to go tan 24 equals, again, we'll say G over 45. (45) times tan 24, that's about 20. So you add 20 to this, you'll get 87 is the other building. Questions, concerns? Okay, pretty impressive. You guys did a good job to start there. Okay, we just got two problems that we're kind of talking about things, or one problem that's extended, that we're going to talk about three-dimensional. Okay? Huh? Yes. It's not an extension. As an aid to understand the problem in 3 dimensions, we sketch two-dimensional representation of the triangles we're working with. So when you're doing this, it's also good to take a step back and to draw what you're doing. Okay, so this one, it says, let's just work through this together here. Whoops. The solid in the diagram was formed from a rectangular prism by removing a wedge. Okay, so remove the wedge. HD equals GC equals 5. Okay, so these are both 5. EA equals FB, they both equal 2. Okay. AD 6 and AB 8. ED is 6 and then AB is 8. Name 4 rectangles in the diagram. Name 4 rectangles in the diagram. Just with letters. What's that? H, say that again, H, E, F, G, yeah. H, E, F, G, so he's talking about here. That's a rectangle, good. What's that? A, B, this one right here? Okay, so A, B, F, E. Okay, there's 2. A, D, C, what? A, B, C, D, good. A, B, C, D, the bottom. Okay, and the last one? Right, the back here, H, D, C, G. Okay, good. Calculate the measure of angle HEA to the nearest degree. We're trying to figure out the angle measure of HEA. So this measure here, HEA, so it's going down, so it's kind of interesting. What? So what helps is to draw two-dimensional. So it's talking about. So let's take this face. I'm just going to turn it to the board like so. So I'm talking about is, you guys see this is slanted here, right? So I'm going to have H. It's going to slant down to E. Goes straight down to A. And then draw back to D. And then connect them. That's the face we're talking about. They want this angle here. Are we good? So all of you guys, I took the side of it, and I just flipped it out so we can see it two-dimensional. This is two-dimensional, right? I've drawn it flat. Okay? Anybody know any strategies to figure that out now? Yeah? Close. Close. Not two triangles, though. Right. I want to draw a line like so. Because that's helpful, because what's that worth? 90. So we're just trying to figure out that sliver. Okay, so now how do we do that? Well, think about what we know, guys, gals. What do we know? Do we know what HE is? We don't? Okay, do we know what DA is? What's that? So that's 6. Okay. What else do we know? Correct. How did you do that? Oh, you did this here, right? We know EA is 2, and we know that HD is 5. So we subtract 5 to 2, so that piece is 3. I know it's not to scale, but good job. That's problem solving right there. Let me explain that again. They tell us up here that HD is 5. This whole distance here is 5. They tell us that EA is 2. So we go 5 minus 2 to get this right here is 3. Why is that important? Because now we have how many pieces of information? 2. So now we can figure out the rest. So we're going to go, we're finding this angle here, opposite, adjacent, tangent, x degrees is 3 over 6. X degrees is tan inverse of 3 over 6. So your x degrees is 26.56. Is that the answer? No. You have to add that 90, right? It wants this whole corner. It wants the whole corner, not just that sliver. We just found the sliver. So we add 90. So x is 116. Say nearest degree. It's 116 point, so 117, yeah? $117 degrees is what it is, which is angle HEA. Questions? Not too bad. Okay, we just got a couple. We have part C and D here. Same problem. All right. Calculate the measure of angle HFE. So let's look and see what that's talking about first. HFE. So it wants HFE. That's interesting. So it wants that there. So you're making HFE. So if you were to draw HFE, it wants to know what that angle would be. So going diagonally from H to F, and then what angle would that make? So if we draw this, in terms of what they're asking, it looked like this two-dimensional. You'd have and so we're going for here. Nope. Rectangles, they don't bisect. Yeah, rectangles don't bisect. Good question. He said, wouldn't that just be 45? The reason it's not, this angle and this angle, see how, is this side the same size? No. If it's a square, yes, but rectangles, no. Okay, good. So the next thing we want to do is what? Let's figure out what do we know in terms of side lengths. We know that EF is 8. Whoops. Okay, good. All right, do we know anything else? HF is 6. Okay. Is it 6 for sure?
No, because it's on an angle.
It's on an angle. Is there any work we can do to find HE? Oh, I have this written backwards. Sorry. This is an F. Is that right? I think I had mine backwards.
Like in the last one?
Yeah, Pythagorean Theorem, you're on the right track. Pythagorean Theorem with what, Luke?
In the last one I had the 6 and the 3.
Right. Okay, so he's talking about this, guys. The last one we have H to P was 3, to E was 6, and we can do Pythagorean Theorem to find out that diagonal of HE is, which that's what that is. It's the same spot. So you're breaking things down into 2 dimensions. So here, do you want me to pause and go to the previous picture?
Oh yeah, we had 3 and 6.
Yeah. So we had, if you look back at your previous, this is still a triangle. It's 3-dimensional, but it still makes a triangle. If we do Pythagorean Theorem, we can figure out what that is. HE is HE. They still have the same HE. Okay, when you do that, you're going to get 3 squared, which is 9, plus 6 squared, which is 36, equals x squared, in this case. So it's root 45. You just leave it like that. That's fine. Why is that important? Because now we have 2 pieces. This is a 90, right? It's a rectangle. Opposite, adjacent. You go tan inverse. And that'll kick out your degree measure. What'd you guys get? 40, good. So angle H is 40 degrees. Good. One more. Calculate the measure of angle HBD to the nearest degree. Okay, does everybody have this? I'll wait for a second. So I'm going to go back to the picture. I might even do D on the previous page. I think it's easier when we can see the picture with it. HBD. Yeah, we'll see what they're saying. Okay, everybody's got it? All right, we'll wait. All right, so take a look at the last one here. So it wants angle HBD. Okay, very similar. So HBD is going to go down, and then, whoa, and then back. So it is literally a 3-dimensional angle. So like, what's that slice going to make? Okay, so you guys just write on your, this is D. I'm doing D on this page so we can kind of see. All right, so I'm going to draw a picture, 2-dimensional, what I want. Let's go ahead and get a, okay, so then we have my H, my B, and my D. What's going to be helpful here? Well, yeah, but I mean, like, what can I steal that can help? What I see is I see this right here. This is a right triangle down here, and that's a side of the HBD. I know it's really hard to look at three-dimensionally. I understand that's tough. So we're trying to find the HBD. So if I do BDA, this triangle, they shared BD. And we know some of these information here from above. Okay, I'm doing that to get this, which is my hypotenuse. Stay with me. So you'll see what I'm talking about. I'll show you right here. Look. So this is DAB. So we know what AD is, don't we? It's 6. We know what AB is, don't we? It's 8. What? 6 and 8. Are we okay? So why is that important? Again, I use Pythagorean Theorem, and I can figure out BD is, and now I'll know what BD is. Okay? So it's going to be 36. Whew. It's 36 plus 64, which is nice because that's 100. Square root of 100 is 10. BD is 10. What's that? What else do we know any other information? Yeah, HG is 5. Perfect. So now we know that HG is 5. We're good to go. We're finding this right here, right? HBD angle. So tangent, opposite over adjacent. Tan inverse of 5 over 10. I think we already did that one, didn't we? Yeah, 27. We already got 27 earlier. So angle HBD is 27 degrees. Again, I know the three-dimensional is tough because your piece of paper is not three-dimensional. Okay? Again, draw it into 2 dimensions is the easiest thing you can do. All right? Okay, I'll pause the video.